Hello and welcome to the course of HDL Digital Circuit Design. Today's topic is Finite State Machine. This is the part 2 of previous video, Concept of Finite State Machine. Myself Shilpa Rudravar, Assistant Professor, School of ENTC Engineering, MIT Academy of Engineering, Ayandi, Pune. So in previous lecture, the link of that particular video will be putting in the description box. So you can go through that previous video. So what is meant by digital circuit? What are the different types of digital circuit? In that we have seen combination circuit and sequential circuit. In combination circuit, output depends upon present state or present input, and in sequential circuit, output depends upon input as well as the present state. Now in second point, that memory component is not there in the combination circuit, it is there in the sequential circuit. Feedback is not present in the combination circuit, feedback is there in the sequential circuit. An example is AND gate, full adder, decoder, mux. These are the examples of combination circuit, and flip-flops, RAM, state machine, these are the example of sequential circuit. So we have seen that traffic light signal controller as well as automatic floor cleaning robot is one type of finite state machine. Now what is meant by finite state machine? It is having certain states which is countable. These are finite, we are able to count it, and it should be more than one, and it is having input. Depending upon that, output is going to change. Example is bottle filling. If bottle is available on the conveyor belt, that too at below nozzle, so it will be detecting that. After that, it will be filling the bottle. Once the bottle is filled, cap will be put. So that is number of states. So water is available, water is filled, so everything that are the states. So this is the input, states will be there. Depending upon that, next state as well as the output is going to decide. So this we have seen in the previous video. So finite state machine is a computing machine having fixed state as well as the input. Depending on that, the next state as well as the output is going to change. So it is a combination of combination circuit as well as the sequential circuit, where this flip-flop or resistor is there, which is the memory element. So input and the present state will be deciding output and the next state. Here again, the sequential circuit FSM is divided into two parts, Mealy and Moore. So what is meant by Mealy? In Mealy, my next state as well as output depends upon input as well as the present state. Again, I'll be repeating it afterward. So here, these are the states. Circle indicates state. The name is A, B, C, D. These are the name of state, and notation is 0, 0 for A, 0, 1 for B, 1, 0 for C, and 1, 1 for D. And on the transition, this is called as a transition. On that, X by Z is written. X by Z means X is the input and Z is the output. So input by output is written. So this is my suppose present state. I am here. So my next state will be this if input is 1, and in that case output will be 0. So my next state as well as this output depends upon my present state as well as this input. If input is 0, then my next state will be same, that is A, because self loop is there, and output is 0. So in Mealy, my output and next state depends upon present state as well as the input. So for that, this is the combination circuit, this is the resistor, which is the memory element. So input is there, it will be processing on that depending upon present state, because this is the flip-flop, it is having its state. So this is also acting as an input to this combination circuit. So my next state depends upon input as well as the present state, as well as my output is also depends upon my input and the present state. So here you are able to see this output depend upon input and the present state. Now what is Moore? Moore is the state dependent. Now here you are able to see these circles. In this circle, that 0, 0 is mentioned, which is the A state, same like this. But inside this circle, after this state is mentioned, output is mentioned. So whenever you are in this state, output is 0. If you are in this state, output is 0. If 1 is written over there, means output is 1. Here my output is depending upon input also, but here it is state dependent. So inside that circle only, that state only, your output is decided. Now how it is explained in the diagram, that this is the combination circuit, this is the memory component, and this is the output. So my output depends upon present state only. So sorry, my output depends upon present state only. So यहाँ पे in this particular side, input is given, combination circuit is there, and this is what is the resistor. So next state will be getting depending upon present state. So this output depends upon present state only. So that is what is the Moore. Now we were here in the previous video, we have interrupted at this at this moment I have taken. Now this is the another part. So next state and the output depends upon present state and the input. So example is the pen. So this is the push button pen. Whenever I am pressing this tip will be coming out, or again whenever I am pressing it, this tip will be coming inside, going inside. So over here you are able to see this button which is pressed, which is acting as an input, and this is what is my the next state and the output, we can say. So what is my state? One state, that pin is out, and another state is pin is inside. So nib is extended, that could be a one state, and nib is retracted, that is another state. So depending upon input, whenever I am pressing this, depending upon my current state, because here previously nib is inside, and that's why now after this push button or button is pressed, nib is coming out. So this is my next state, that is state is changing. Now same input I am giving, but now because of state is previously this one, that is nib is extended, now the nib will be retracted. Okay, so this will be the example of this particular machine, finite state machine, that too Mealy. In Mealy, output and the next state depends upon current state. So current state, nib is not there, and that's why whenever you are pushing, it is coming out. Now depending upon this as well as input, next state is going to decide. So this is what is a Mealy kind of machine. Now what is the difference between Mealy and Moore? So same thing we have seen earlier. So same I'll be repeating over here in terms of points. Now this is the diagram that we have seen for the Mealy, and this is the diagram for Moore. So here my output and the next state depend upon input as well as present state. So this memory will be giving you a present state. So depending upon input and the present state, my next state as well as output is going to decide. Now over here my output depends upon present state only. So if state is something over there, depending upon that only my output is going to decide. So here output depends upon present state and present input, present state and present input. But here output is state dependent. Depending upon present state, your output is going to depend. Generally it has fewer state than the Moore. So whenever we are going ahead with the topic, how to draw the state diagram for the sequence detector, so that particular time you will be understanding what is the meaning of this. So in Mealy, that many bits you need to detect, that is sequence is 101. So you require 101 means 3 bits are there, you require 3 states. But here if you need to detect 101 sequence, so you require plus 1 state, that is 101 means 3 bits, so plus 1 means 4 states you required here. So generally fewer state in Moore machine, generally it has fewer state than the Moore machine. So here it requires 3 states, here it requires 4 states. The value of output function is a function of transitions and changes when the input logic on the present state is done. So I have told you on the transition you are writing X by Z, input by output, but on this, in this Mealy or Moore output transition, you will be writing input only. So over here X by Z you are writing, here you are writing only X, that is the input. Mealy machine reacts faster to inputs. They generally react in the same clock cycle. So Mealy machine is faster than Moore because once input is changed, your output is going to change. You do not have to wait for clock. But in Moore, output will be there, change will be there when the clock is applied. So you have to wait for the clock. So Mealy is faster than Moore. Here, this is the Mealy state machine has been drawn. There is the Moore state machine. So I told you what is the basic difference. States are there. Okay. So if here you require 4 steps, for the same implementation in Moore you require 5 steps. So this is example is different. That's why 4 states you are able to see. But same example if you are solving using Mealy and Moore, so you require 1 more state in the Moore. Here output is state dependent. So here you are able to see the states, and inside that the name is given to the state, that is A, and whenever you are in A state, meaning of that 0 is there, means output is 0. So here you are able to see output. Now here you are in C state, output is 1. So here you are able to see same. On the transition, you are writing only input. If input is A is 0, output is 0. That is only input you are writing. But on the transition for the Mealy, you are writing input by output, X by Z. If I'm considering X as an input and Z as output, so I will be writing X by Z. So that is the thing. Main thing I told you, my output and the next state depends upon input and the present state in Mealy. In Moore, my output and the next state depends upon present state only. So hope this part is clear, and this is the basic required for moving ahead for the sequence detector. So in the coming sessions, we'll be seeing one kind of sequence that will be implemented in Mealy as well as Moore, that too overlapping and non-overlapping way. So go through this video again for understanding of sequence detector that we will be covering in the coming session. Thank you.